Now let's move on to the next topic in Unit 3, that is the biomechanics of bone. So in last class we have detailed discussion of what is bone structure and composition. Now in this section in today we are going to study what is the biomechanics, that is the mechanical properties of the bone. So the learning objective of today class is that again we are going to brush up what is the basic structure of the bone, and followed by we will be discussing the mechanical properties, especially where we are going to analyze the stress strain relationship and the viscoelasticity behavior of the bones. And also we will be discussing what are the different loading condition, and what will happen when bone is being exposed to different types of pressures or different types of force. And also we will be have a detailed discussion of remodeling process and fracture mechanisms. Finally we wind up with clinical applications. Now let's move on to why actually this particular topic is important. Because if you have any problem with your bone, like maybe you have a bone pain, or you have any kind sort of a bone disorders like osteoporosis, or in some cases the people met with accidents, they have a fracture in the bone. So if you want to correct these sort of problems related to the bone, or if you want to understand what happened in the bone, first, we need to know what is the bone structure, what is the mechanical properties, how does this bone will behave when we give any sort of pressure or force. What is the point or the threshold for the bone to get break, and in what extent it will get adopt and what extent it will get break. So these are the things, because the bone is not, it's not something which is made up of one particular component. We have a combination of different sort of components, right? So we have organic components, inorganic components. So each and every components has different or its own mechanical properties. Some will offer the strength, some will offer the flexibility. So how which one will get dominant when we have different sort of sources? Okay, that is actually they will have as a designing point to have the that is results for different sort of force. Example like breakaging or deformation of the bone, that is called bone remodeling, and so on. So that is the reason that we have brought this particular topic, to get to know, understand what is the basic concept of a mechanical bone and mechanical properties of the bone. So let me see, let me tell you first what is the different mechanical behavior, and what is the function of the each and everything for the application. So it is very important to study the mechanical behavior of the bone tissue, because we should know, or we should understand what will happen when we given any sort of force and loads. And we also need to identify what is the extreme point or the threshold point for deformation and the failure mechanism. That is the thing, the main concept of main concept to have brought this particular topic in today's section. So, and also we know what is a skeletal section, right? Skeleton function. That is the main function is that we have to that skeletal need to be, that is the bone need to have a very good load bearing capacity, and it offers movement function and also the stability. And not only this, it also giving a protection for very important vital organs like heart, lungs, and brain, and so on. So, and in last class we had detailed discussion on what is the architecture, that is a hierarchical organization of bone, that we have covered macroscopic level, microscopic level, even nanoscopic level. It is made up of the components, that is the collagen and minerals, how it is being influenced in mechanical properties. And why it is very important to study this particular topic, the reason is that if you want to design any implants, that for that also we need to know what is the material mechanical properties of your bone, and also for fracture treatment, and also to proper disease diagnosis. So these are the things that we need to understand bone biomechanics. So this is the topic that we have discussed already, that is a bone structure and composition. Now we will straight away we will move on to the mechanical properties of the bone. So these there are some factors which are highly influenced or highly contribute so high. I mean, highly contribute to decide the mechanical properties. That factors are nothing but a location in the body. That is where the bone is actually located, because the location also decides the breakage point of the bone. Okay, that is the reason we have to see where it's located and what is the age. Age also is a very big factor, because the age, the strength of the bone is not as same as the strength of the bone of old people. That is, young people and old people, they have a different bone density, right? So that also it's another important factor that need to be considered when we are discussing the mechanical properties. Not all the bone of, I mean, not all the same bone. Okay, that is, if you take any femur part, that femur part of the bone will not have the same mechanical properties for all different ages of the people. That is the thing here I would like to convey. That is, the age is also one of the factor that we need to consider. The third one is the degree of mineralization, that is the making of material, that is the composition of the part, that is the density of the bones, that also vary from person to person. The amount of water present, loading direction, in the direction the through which, I mean, direction in what way we are giving load. Okay, that is a stress, that is the loading direction also very important. And finally, the bone microstructure, that is the osteon arrangements, it is plays a very important role, because the osteon arrangement is actually important in case of offering the strength that you can see in compact bone. So the arrangement is very important in terms of mechanical properties. So the mechanical properties of the bone, if you see, the most of the bone behaves an isotropic properties. The reason is that it will change the properties in terms of direction of loading. Because if you're giving the load or stress in longitudinal direction, you can see the bone is very strong, that you can see the experience of strength in high, especially if you apply the load in longitudinal direction. Exactly vice versa, if you give that load in transverse direction, you can feel the bone is weaker. So this is a thing which offers or exhibit the property called an isotropic property. The reason is that you have two main components, that is the material osteons and collagen fibers. So if they are not aligned along the axis of the bone, then you can see the variance in case of in case of bone strength. That is the reason, because in longitudinal direction you are giving the stress along the axis of your bone, that is the compact of the bone. So the bone offers very good strength. Okay, if you're giving transverse direction the same stress, it is exactly perpendicular to the alignment of osteons and collagen fibers. It is not aligned with your collagen fibers, so there is a more tendency that particular point will gain the weaker gain, I mean, move into weaker point. So one point at one extent, it will get break. So these are the things that we need to understand, why the osteons and collagen fibers is very important, why it need to be aligned in terms of applying the stress. So this is the another important topic that we need to consider when we are discussing about mechanical properties of bone, that is stress strain curve. This is a very important topic, because if you see, look out this graph here, the graph is being plotted between the stress and strain. You know the meaning already, what is meant by stress. The stress is the amount of force that will be applied per unit area. The strain is there is a deformation which is being produced for the stress what we applied, that is change in length. This is actually happen in wherever or whatever stress we give in any sort of bones or any sort of tissue or any sort of material. It's equivalent strain you can see. Okay, again it depends on the made up of material, right? So if you see the stress strain curve for the bone, you can see the different regions. The region is called elastic, and second region you can see the yield, third one is the plastic, and fourth one is the ultimate, and fifth one is the fracture. So these are the different stage or different region it will goes to the end, it will meet the fracture. Okay, so elastic is the initial thing that you can see, the bone behavior is very reversible. So that you can that we can experience or when we have a normal activity like walking, no, walking, sitting, standing, and like that. So that is a reversible case. Whatever stress we are applying, once the stress being removed, the body part is begin regain its original shape. That is the elastic property. And the point you can see, the limit, that is the elastic limit, that is the extreme point. Then it's move on to the yield point, the way the micro damages gets to start. Okay, that is the stress is going to be stayed over there. Okay, the stress fracture is going to have, that is the starting point of the stress. You can see the very minimal micro damage. So once that point is reached, then the elastic region will move on to the plastic region. Okay, so here the plastic region, the your bone will behaves like a more like a stiffness. Okay, in elastic region your bone behaves like more toughness. Okay, so here the plastic region your bone behave like more stiffness. So then it also have some extreme point, that is the minimum point, that is the starting point of plastic region, and that is the ultimate stress point, that is the maximum strength the bone can adopt before it get breaking. That is the maximum stress point, that you can see the ultimate point of plastic region. Okay, then still if you are giving the pressure in the region, then the ultimate point will goes into the fracture. That is the actual point your bone get break. Okay, so this is the different region that you can see for the given stress in this, I mean the strain curve. Okay, you have these five kind of region: elastic, and then you have a yield point, and plastic, and ultimate, and the fracture. This is very very important when you are designing any sort of implants, or if you want to do any diagnosis related to bone disorders. So in next class, we will have a detailed discussion of what is the bone remodeling and so on. Thank you.